Hi, everyone. Welcome to another first session on high yield routines. This time we're looking at numberless word problems. My name is Janice Nowakowski, and I'm the district teacher consultant for the Richmond School District, supporting K-12 teachers in the areas of mathematics and numeracy. So the routine numberless word problems sort of describes what it is. It's presenting a word problem or a story problem to students without the numbers to begin with. And they're making sense of the problem and the structure and the actions of the mathematics before we add the numbers. And so this is mostly for operations from kindergarten through grade 9, but it can involve different types of numbers. So whole numbers, fractions, decimals, etc. And numberless word problems comes out of the research from cognitively guided instruction. And some of that research has revealed that often with word and story problems, children just grab the numbers and are compelled to do something with them. So they might like, oh, I'm going to take this and just add them together without actually making sense of what that word or story problem is asking them to do. So that is the essence of numberless word problems. And we slowly reveal more information about the problem and the quantities involved to them as we progress through the problem. So we might ask students to consider what is happening in this story or in this problem. What information do you have already? What information do you need? How does this new information change your thinking about this problem? And then we have students solve the problems and share their different strategies, much like we would do for a number talk. So some resources to think about and find out more information about numberless word problems are on the district blog. So there's the blog address there on the screen. And I do have some examples from some classes I did in the spring. So PowerPoint slides of numberless word problems you can do with your students, and then a link to Brian Bouchart's website, which is the other key resource. So he was the one that really made this routine public. And so like many of these routines, there's a website dedicated to it, and it's all free resources, all sorts of problem banks, and also different ways to do numberless word problems with your students available on his website. So there's the web address there on your screen. So I mentioned CGI earlier, and this, again, this routine comes out of CGI, and CGI focuses on the main four operations, so addition, subtraction, multiplication, and division, and looks at the main types of problems. So join problems, so bringing together, separating problems, part, whole, compare problems, and equal grouping problems. And so all of mathematics, the operations are connected to those five structures. Within the join problems, for example, you have three different types of join problems. When you don't know the result, which is what most children are exposed to. So 3 plus 2 equals what? And then you have a change unknown problem. 3 plus what equals 5? And then you have a start unknown problem, which is probably the most difficult for students. What plus 3 equals 5? And those structures can be used across the grades for all different kinds of numbers, fractions, decimals, numbers in the thousands and millions. The same structures are important for students to think about so that they can make connections between operations and also develop algebraic thinking. So here's an example of one of those types of structures at the bottom. I cut up 5 apples to make a pie, but it is not enough. I need 8 apples for the pie. So how many more apples do I need to cut up? So we know how many we need, that's the result. We know how many we started with, that's the start, but we don't know that middle number of apples that we need to cut more of. So that would be a change unknown join problem. And you can find out more information about this on my blog, but this is kind of an important thing to think about when we're designing these numberless word problems, is what part of the problem is the student going to figure out? So here's an example. This was on like a mini whiteboard in a grade 1 and 2 classroom. The first time I wrote it out just said a squirrel has some acorns. He collected some more. And I asked the students, you can see at the bottom, what do you notice about this math problem? And what do you wonder? And a lot of them said, well, there's no numbers in it. How many acorns are there? Like, this isn't a math problem because there aren't any numbers. And we asked Have them ask some questions. Where did the squirrel, grade 1s and 2s, where did the squirrel find the acorns? What kind of squirrel was it? Where did it live? There were all those kinds of questions as well that contribute to the story. And then the second go, I erased the word some at the beginning and said the squirrel had 7 acorns. He collected some more. And then the next reveal was the squirrel had 7 acorns. He collected some more. Now he had 13 acorns. How many acorns did he have? And that's the math question that they needed to collect or think about. Okay, so think about what sort of teacher move might you do as students are giving different responses. So you can see there on the left, some students said 20 acorns. There's 20 because they just did that number grabbing thing. They saw 7, they saw 13, and they added them together. And so what would you do as a teacher? So reread the story. I often say, let's play this story in our mind. Make a picture of a squirrel holding 7 acorns, and then he goes and gets some more. Now he has 13. So, you need to sort of help them visualize, draw a picture, act it out to help them understand the structure of this type of problem if they haven't been exposed to it before. All right, another example. So in the same class, we did another type of numberless word problem next with a start unknown. And again, this is quite a difficult structure for many students. So Colin had some marbles. He got some more, is what it originally said, for his birthday. Now he had lots of marbles, is what it said. So then the structure, I added the numbers. Colin had some marbles. He got 20 more for his birthday. Now he had 52 marbles. And then sometimes that's where we stop and we ask, what is the math question we need to figure out? And that sometimes is hard for children too, but that helps them think about the structure of the mathematics. So how many marbles did Colin have before his birthday? And then we can write that as an equation to support students and then have them share their different strategies for solving that problem. Here's a snow geese problem. This was in a grade 2 and 3 class over at Garden City. There were some snow geese on the field, 20, and it said some more flew to join them. I did the notice and the wonder at the beginning. 25 more flew in to join them, which is happening right now. Here's some of their noticing and wonders. This is just a sentence sitting there. There's no numbers. There's no plus or minus signs. There are only words. How is this a math problem? How many snow geese come to our field? That's a great wonder question. But again, the first time you do this with students, these are the types of things that come up because they're not used to it as a routine yet. In both of these classes, these were the first goes with numberless word problems. And then they come to understand why we're doing this and how we're making sense of the problem and the math first before adding the numbers. So here was this problem. There were some snow geese on the field. 25 more flew in to join them. Now there are 52 snow geese. And then what would the math question be? How many snow geese were on the field to start? And you get children to tell you what that question would be. And then here are, again, as the teacher, the students are now, maybe they turned and talked and shared their strategies. And I'm recording the different ways that they figured out how many geese were there to begin with. And then we compared their strategies. Here's another example. Adam had $3 in his piggy bank. So it originally said had some money in his piggy bank. He took some juice boxes to the recycling depot and got some money in return. Now he had $4.50. So here were the questions that they asked before I added the numbers. Well, how many juice boxes did he return? How much money did he get? So we told them a little bit of information, but they have to figure out what that money was. And then think about how could you extend that for some of your students? If he received $1.50 in recycling, what kind of juice box, how many juice boxes would he return? How much do you get for each juice box? Does it matter the size of the juice box? All sorts of different mathematical sort of inquiry questions students could investigate as an extension to the numberless word problem. So here's a sequence. This is a grade 3 class. This was just last week, so the beginning of the school year in terms of how I would work through a numberless word problem. So I took a photo after each stage to go through the whole phase. So this is what we started with because there was a lot of talk of pumpkins in this class. There were so many pumpkins in the farmer's field. They picked a lot of pumpkins to sell at the market. They left quite a few pumpkins in the field for the next market. And again, you might need to unpack some of that language first with your students. What is a farmer's field? What is a market? Why might they have another market? Those kinds of things. So then we talked about where are the words in this math problem that talk to us about quantity. And so we underlined these words: so many, a lot, quite a few, just to have them focus on what we were going to pay attention to and what to look for in terms of numbers. And then I added a first quantity. There were 280 pumpkins in the farmer's field. What you could have done before that, I didn't in this case, is have them estimate about how many pumpkins do you think might be in a farmer's field? Have them make sense of a quantity. Would a farmer only have 10 pumpkins? Would a farmer have 10,000 pumpkins? Is that a reasonable amount? Maybe it depends on the size of the farm. So do some of that sort of thinking as well before you add numbers. So then we had them think about, okay, so if there are only 280 pumpkins and that we know they picked quite a few, but there's going to be quite a few left, what would be a reasonable amount of pumpkins for them to pick? And this is where that number sense really comes in. There's nothing to compute. We really want students just thinking about that quantity. So then we added, there were 280 pumpkins. They picked a lot of pumpkins. They left 150 pumpkins in the field for the next market. So now their point is, what is the question we want to ask? What is the math question we need to figure out? Some students might have already done the math in their head and want to share their answer, but you have to really set that tone that that's, yes, the answer is important, but we are going to think about different ways to solve that problem together as a class. So we circled the a lot and the question, how many pumpkins did they pick? So then I had students share, they turned and talked in this class, and they thought about different ways that they could solve this. How could they figure out how many pumpkins they picked for the first market? And then have them continue to think of another strategy, and you're sort of monitoring the class, and then you have them share their strategies and you record them just like for a number talk. So then we took the same structure and I just changed the numbers as a follow-up problem. And so this was a grade 3 class, but I wanted to provide those first sets of numbers to provide access for all students. We're just looking at hundreds and tens. And there wasn't a lot of, mental mathematics involved. It was really focusing on place value. But then we upped the numbers to 432 and 158, and then thought about the strategies that they needed for that. And not as many students were ready to share out loud about that. The thinking is more complex to explain, but you can see some of the students' strategies there. So again, you get a really good sense as you're listening into students and they're sharing in terms of where they are with their place value understanding, their understanding of mental math strategies, and adding and subtracting. And again, you can do this for multiplication and division as well, with different types of numbers across the grades. So again, digital versions, once you've created a couple on slides, whether you use Google Slides or PowerPoint slides or something else, you can just adapt them. So this was a grade 1-2 class at Tate at the end of last year. And you can see how I've got all my slide bank at the bottom, and I just have transitions built in so that one part is revealed at a time. So I do a little photo or a visual, so students know that this is going to be something about shells. Some of them might have background knowledge that these are actual mussel shells. And then, so this is what it would look like. We would reveal one part. And again, those are just built-in transitions on PowerPoint. There were some shells at the beach. So I have students, I often say, play this movie in your head. What's happening in this math problem or math story? I use some shells to make a pattern in the sand. So about how many shells might you need to make a pattern? There were some shells left for others to use. So again, there were some shells, I used some, but there were some left over. So then I'm revealing some numbers now. There were 32 shells at the beach. I used some to make a pattern in the sand. There were lots of shells left for others to use. Okay, so how many shells do you think I might have used to make a pattern if there were 32 there? How many might be left for others? Turn and talk, share your thinking. There were 32 shells at the beach. I used some to make a pattern. There are 18 shells left for others to use. So what math question could you ask? And then the students reveal, how many shells did I use to make a pattern? And then they share their strategies. Here's a grade 4 example. And again, in 2 different forms. So this isn't just all at once. Michelle bought 2 different lollipops. One was larger and cost more than the other. The smaller one cost less than $1. She only had 1 bill, but it was enough to pay for both lollipops. And she would have some money left over. Now that's a lot of text and a lot of language for many of our students for a variety of reasons. And so another way to do that is to break that down onto lines like I had done previously. But I wanted to show you this as another example. So we've added again a cost for one of the lollipops in money notation there. And then I've added the amount of the bill that she had. So she had a $5 bill. So you have to figure out the cost of the other lollipop, and then maybe you'll get some information about the change. Oh, yeah, she's got $1.75 left over. So now we have enough information to figure out the cost of the larger lollipop. What is the math question, etc., and then have students share their strategies. This is the other format that I use. Again, once I know the students in terms of what they need to support them. And again, this sort of information line by line is supportive of many students in terms of a lot of information coming at them, or also students that are English language learners. Providing visuals along the way as well can support students. And then after we did a couple of these numberless word problems, we asked them to create their own math stories or their own math word problems. And this was focused on decimal numbers. And we gave 2 suggestions of context that they might use, a money context or centimeter and meters context. And then they wrote their own, and then we shared those. So another extension for numberless word problems. As you're doing a numberless word problem, you might be asking some of these questions. And these are from Brian Bushart's website. What do you know? What information have you been given? What do you understand so far? What kind of problem could this be? So they're thinking of the mathematical structure. For our English language learners, 3 sort of adaptations: write 1 line at a time, leaving a space in between those lines and sentences. Remove distracting and unnecessary language. So doing that English simplified to make this more accessible for our students. And include pictures for nouns and verbs, and action or movement, arrows or gestures, those visuals to support students' understanding of the mathematics. And just thinking about how this connects across the curriculum, so many curricular competencies in mathematics K-9 are being developed during this routine. It mostly focuses on number operations, but also some number concepts as well. And you can see that across the grades there on the right. So I want you to think about how you'll use this high yield instructional routine with your students. And thank you for joining me.